Another streetlight. I do take quite a lot of streetlights apart. I've got a thing about streetlights. I find them quite interesting. This one came from Banggood, and the thing that really caught my attention was the large area of the solar panels on it. So the listing in Banggood describes it as 20 watt 40 LED solar radar motion activated central wall street light for outdoor, and it was $36 US. Someone was asking recently, why do I buy things in dollars? And whatever I buy, I tend to buy it in whatever currency I've got the most of in PayPal at the time. At the moment, it's American dollars, because I'm very, I don't really hold to any particular currency. I regard the American dollar as the currency of the internet. So, 36 American dollars, and it had 2 reviews. Where does it say the review bit? 2 reviews. I don't see the review bit. Right, okay, moving. 2 reviews. 14 sold. The 2 reviews, actually, if you consider 14 sold, 2 reviews is not very good when both the reviews are bad. And that was the final straw. I had to buy it to see what was so bad. So this looks like aluminium, but it's actually plastic. It comes with a metal clamp. I take it this is steel. Yes, this is steel. So this is the bit that can rust. And it's held in place by these plastic pillars with a stainless steel nut inserted underneath, and then a stainless steel bolt put down for the top. I'd like to stress that this is, I know Banggood support a lot of other YouTubers. I tend to avoid accepting sponsorship unless it's something really special, because it lets me be more honest about things. So this video is brought to you entirely by Jägermeister this time. Jägermeister with its strange medicine-like orangey goodness. So the other side of this light has the reflector. I wonder, are these reflectors just a sort of token gesture thing? Because ultimately, these lights don't need sort of collimated in the same way that a traditional tungsten or discharge lamp would. So you've got an array of the, I guess, half-watt LEDs, because there are 40 LEDs and it claims 20 watts. It's got what looks like a passive infrared lens, but I'm guessing maybe they've updated the technology since, because the unit, I hid it behind cardboard. I'm pretty sure this is radar, because the passive infrared can't see through cardboard. Radar can, the sort of radio detection. And that makes sense. I think it's becoming cheaper to do that, because a few capacitors and a radar transistor and a custom circuit board is a lot cheaper than the pyroelectric sensor used in these. Now, here is the problem. It's a nice enough design, but I don't think I'm going to be able to open this, because it's clear everything has been put in from the other side, and then they've glued the solar panel on. And this is made of glass, and the glue they've used is silicone. That sort of gooey, rubbery silicone. And if you look at the back of it, it is optimised for that. It's got large, flat planes, and that means my chance of being able to prise the glass off the other side of this without breaking it. It is glass. I gave it the tooth test, and if you scratch it, it's very scrunchy. It is glass. That's quite appealing in its own right. I don't want to break this solar panel. I want to keep this intact. And that means the only way I can think of opening this to gain access is by dremeling it open around here and just kind of trying to get it open that way. I'm not really sure how this is going to go. The batteries inside it are 18650s by the look of it. I can see a clump of about 3 of them under here. And I like the fact that, it's got the vents for the battery explosion, and it also lets the water out. So it's got a port that it can breathe, so hopefully you're not going to get too much condensation inside. Finally, it's got this on-off button. And I'm guessing then that the light sensing is done by the output from the solar panel, which it does appear to be. And there is one of the first weaknesses. When you turn it on and it gets the slightest hint of daylight, it's not a very smooth transition. It starts flickering and undulating at just the transition. It will start flickering on and off. When it's actually viewed outside, I held it overhead. I wouldn't put this at the top of a lamppost, because I get the feeling that under extreme storm conditions, it's going to be flexing the plastic. I'm not sure how well that would last. I wouldn't want this landing on my head from above. But it puts out a decent amount of light. It's a sort of, it would be good for a yard light. It's not that bad at all. But let's take a look inside. And to do that, I'm going to have to Dremel it open. So let's pause while I Dremel it open. Right. So now that's thoroughly Dremeled open. The problem with Dremeling plastic things with lithium batteries in it is you just don't know where the smoke's coming from. Is it coming from the burning plastic, or is it coming from the lithium battery? I don't think I've cut through the battery. So what have we got in here? There's a... I have to be careful about these wires in here. I don't want to damage anything. So let's lop the solar panels wires off. There we go. And see if we can separate it. Right. So now maybe I can actually gradually separate the plastic from this afterwards. But the main thing is, nice solar panel. Oh, hold on. Let's get the meter in. Let's stick it to something optimistic. Let's put it in the 10 amp range. Set it to DC current. Strip these wires. Silicon, which is quite nice. Oh, look at that battery. Oh, is that just a single big battery? It looked from its size like a cluster of 18650s, but now I'm seeing it's just one big fat battery. That's quite interesting. Unless it is some sort of other battery pack. We shall investigate that shortly. Intriguing. They could have fitted quite a lot more in there. They could have fitted 2 of them in there. All right, we'll look at that after. Have patience, Clive. Have patience. We can see that afterwards. It's just greed for all the information at once. So let's stick the meter across these leads on short circuit current. Let's get these clips on here. I'm not going to be able to light the whole thing at once. That's a snag. But what am I getting here? Oh, is that it? It's not lighting the whole thing at once. It's not inspiring me. Okay. Hold on. Maybe I could have used a wee dinky meter after all for this. Oh, that's better. Oh, no, it's not. But I suppose it's quite a distance from the light. It's not being covered completely by it. Yeah, I'm not going to be able to test this completely. It's kind of not really what I was expecting, but not to worry. I should test it in actual sunlight. The downside being that on the Isle of Man, in winter, just after Christmas, just before the New Year, there isn't much sunlight. So let's take a look at this. We have our LED panel, which is no heatsink other than the aluminium substrate it's on. We've got this big fat battery pack. Let's whip the sensor off here and see if it is passive infrared or if it's radar. I'm thinking it might be radar. Noting it says 3.2 to 3.7 volts. It's radar. You can see the little telltale zigzag trace here. There's the little radar transistor, and this is almost certainly a BISS 0001 chip. This is where I'm completely wrong, isn't it? It's a BISS 001 chip. Such a clever thing. They discovered that with the radar Doppler detector, you've basically got this little transistor is oscillating this at very low energy. The word microwave, don't think microwave oven. We're talking microwatts, milliwatts here. It's a tiny amount of radio energy. So it puts out a small amount of radio energy, but as you move forwards or backwards, it causes a reflection to go out of phase, and it means that the current this little transistor draws undulates up and down, and that can be detected by the traditional passive infrared detector chip. There's room for other stuff on here. There's the switching, which is based on a simple transistor amplifier circuit here, and then a cluster of transistors in parallel by the look of it. What are they? The number on them is A2SHB. They're little MOSFETs. And then we've got 2 1 ohm resistors, so half an ohm effectively, because they're both in parallel. But there's the ability to put another 2 in to reduce that even further or change different values. This thing does have the facility to put the infrared sensor in. I wonder why they've included both. Maybe it's just keeping their options open. And I'm wondering then what this little chip here would have been for, because there's a little 8-pin chip. It might have been a ubiquitous 8-pin microcontroller. I don't know if the passive infrared would also go to the same BISS chip. Interesting. This battery here is very intriguing. It's held in by a cable tie. Is this going to be a big, fat, single lithium cell? It looks like it, if it is lithium. Shall we take the sleeving off this? I think we should take the sleeving off this. To all intents and purposes, this is just one big fat lithium cell by the feel of it. So I'll be quite cautious as I stick a knife into it. That's not a good idea, is it? That just makes it more appealing. That wasn't the best way to do it, but not to worry. Ooh. I'm kind of surprised that it is a big individual, just a single cell. I wonder the capacity of this. I can test that. I can put this on charge if this is a standard lithium cell, and I can see how much capacity it has. Is there anything printed on it? No, there's not. It's a big, anonymous, presumably lithium cell. There is a little circuit board under here. Is that just terminals? Or is there a bit of protection? I am seeing protection. I'm seeing, I don't even need to take cover off, I can see a double MOSFET, a really big one, and then the DW01. So it's a single cell with that protection. Let's check the voltage across that. Voltage. I think this is fairly low. Could be wrong, but I think it's low. 2.8 it is at the bottom end of its range. That, the light didn't seem to come with much charge in it, and well, we don't have much sunshine here. And it's been sitting indoors since it arrived. And that leaves the LED module, which is not going to contain many surprises at all. It's just going to operate directly at that voltage. And it's going to be a parallel array of LEDs. It's still connected to that, so it should light, because there's nothing coming from the solar panel at all. So, yes, what else can I say about that? It's not going to be running at full output because this is already quite low. And that means that with this thing, if it's putting a charge in during the day, and it's cloudy and overcast, it's not going to be super mega intense, because as the voltage of the lithium cell falls, it's going to be echoed at the LEDs. So when the unit's going to be at its brightest when it's had loads of sunshine, it's charged this fully up, this monster of a lithium cell. But when it is run down, as it runs down, the voltage to the LEDs will lower, the current through the LEDs will lower, and it will just gradually lose intensity. Another thing that's worth mentioning here is that the unit does light at low intensity all the time when it gets to dusk, and it only kicks up to the higher intensity when the passive infrared detector detects the movement, and then it turns these transistors on and boosts the intensity up. And that is more or less it. They're planning on a lot of current, because here is the connection from the solar panel, and they've got a couple of big fat diodes going out to the, well, I think they're going out to where the battery is connected to. Yeah, the battery's going along over to here. And I'm guessing, yes, the solar panel is charging via these two big diodes here, and that is fundamentally, it's relying on the fact that the protection's built onto the battery to actually shut off the charging. It's a really basic design. The one thing that's going to make or break this design is the quality of the lithium cell, quality of the LEDs, well, that's two things, and the quality of the solar panel, which is the third of the one thing that's going to make or break this design. And the whole thing is rather annoyingly glued together. And yeah, let's bring up the other bit again. I would like this solar panel out. I might just leave it there. Maybe I'll try and glue the whole thing together again. Not really convinced that's going to result in a good result. But so there we have it. I was going to say Poundland's outdoor solar streetlight. It's not. It's Banggood's outdoor solar streetlight. The one thing that has surprised me in this is that it does seem to have a big solar panel. I really want to test that under proper conditions. I'll take it out tomorrow, and then I'll leave a comment in the description down below telling you what its output was and whatever weather we have. And I do want to test this because this is an absolute monster of a cell. I quite like this just on its own. I could give you the number of this cell just by getting a measuring tape. One moment. Okay, let the measuring begin. Can I also mention British ruler, metric on one side, imperial on the other. Metric on one side, imperial on the other. And this one's great. This one's fantastic. I think this might have come from a pound shop as well. It's ridiculous. This one has 1/10 of an inch graduation, which for electronics is fantastic because well, electronics being electronics, the traditional integrated circuits like the PIC, say 12F629 microcontroller has its pins in a 1/10 inch spacing. It's like metric imperial. But our measuring tapes also have imperial on one side, metric on the other. And to be honest, many instances we just use whichever is going to be the closest to, you know, if it's a small measurement, millimeters. If it's a big measurement, inches and feet and inches. It's just how it goes. So let's measure this in millimeters, since this will be measured in millimeters. I would say that's about 32 millimeters. Is that a standard size? I think that is. And the length is about 70 millimeters long. One moment, please. I'm just going to see if that's a standard battery size. It is. It's a standard battery size. As with all these round lithium cells, it's a 5-digit number, 32, 32 millimeters diameter, 70, 70 millimeters long, and a 0 at the end because it's designed to accommodate the rectangular batteries as well with the length, width, and height. But so this is a 32700, and the typical capacity of these is 5 amp hour. So that is going to be interesting. Going to have to test that now, and once again I shall leave that in the comments down below, in the description down below once I've actually done that. So I'm going to have to whip this cable off and then charge it up. So yes, I'm going to do that right now. So that more or less concludes this video. That's how you completely destroy what was once a lovely solar garden or yard light. And, well, to find out what's inside, which it turns out is actually quite respectable. It does have that slight thing that the dusk sensing does result in a slight instability and flickering. But beyond that, I mean, it's not that critical. It just, you probably wouldn't notice it. It does have that nice feature that it lights dimly at night. I see there's what looks like an LED in here to show it's charging. Is that even going to be visible through the case? No, it's not. It's just there. But it's quite nice. It's got the feature that it lights up dimly when it comes on, but then it increases intensity when you disturb the passive infrared detector. You actually, well, not the passive, in this case it's the radar detector. So that's quite neat. I shall be giving this further testing. Some considerable amount of experimentation later with the unit powered from my bench power supply to emulate different voltages, and then lots of probing about in the circuitry. I can explain how it all works now, so I'm just going to turn that off because it's a bit glaring at the moment. I've kind of got this upside down because it just so happens that's the way I reverse engineered it, so this is how I'm going to show it. The unit has 3 sets of connections. It's got the solar panel input connection here, it's got the lithium battery connection here, and it's got the LED output connection here. And when it's charging from the solar power and the voltage is higher than, well, 0 basically, it does a few things. The positive connection is connected to the lithium positive via these diodes, so it then charges the lithium cell via those diodes. They just prevent reverse leakage, and it relies on the internal protection in the cell to actually turn it off once it reaches the full voltage. This seems to be a fairly common thing. It also lights this little red LED down here, but not very high intensity. It's got a resistor marked 472, 47 and 2 zeros is 4.7k resistor in series, so it really does just barely glow. That's all it's intended to do, it's just a sort of activity indicator. It also turns on this transistor via this resistor here. And when it turns this transistor on, that one then, it does two things. It turns this transistor off, it shunts its gate, its base, should I say. And that transistor would normally, in the dark, when this transistor isn't turned off, this would turn on and would power the LEDs via this 5.6 ohm resistor, 5R6, 5.6 ohms. So that's what lights them at the low setting. But it also, when it detects the daylight, it sends a disable signal to the this little regulator here, and this is a 3-volt regulator for the sensing circuitry to provide a stable voltage. Lots of capacitors here just to provide extra stability. That enable signal, it means that during the daylight, this whole sense circuitry is just turned off completely, which makes sense. When it gets dark, that transistor turns that transistor on standby mode, but also turns the circuitry on. And when the circuitry detects movement, there is a link across to the base of these gates, should I say, of these MOSFETs, and it turns these MOSFETs on when it detects movement. And it's got the two 1 ohm resistors in parallel to give half an ohm, and that results in a much higher intensity, but not quite the 20 watts they're talking about. I measured it with an equivalent fresh battery, 4.2 volts, 1.7 amps, equated to about 1.7 amps would equate to about 5 watts output from the LEDs at their sort of 3 volt level that they'd normally be at, around that level, sort of current. Other things worth of note, this little chip down here has an inductor with it, and it actually is a 3.3 volt regulator, but when the voltage of the battery is above 3.3 volts, the output, because of the type of regulator, it just passes that straight through, so you get a higher voltage there. It's not just 3.3 volts. However, when the voltage drops below that level, then this little unit kicks in and uses the inductor to actually boost the voltage up to 3.3 volts to maintain a steady voltage, and that then gets regulated further by this DK. I'll read what it says in it. DK equals COZ or COZ. I'm guessing that's just a 3 volt regulator because I measured 3 volts in the output from that. So two-step regulation, but that might also be down to the powering the circuitry that's missing here, which is a passive infrared detector, pyroelectric device, and also I'm guessing this 8-pin chip here, because it doesn't have the standard pinout of the microcontroller that we often see. I'm guessing it's actually a dedicated passive infrared chip just for that, a simpler arrangement. But however, in this instance, they've used the BISS0001, which is one of the most standard chips. It does require quite a lot of capacitors for its, because it's quite a sort of, shall we say, an analog or linear chip inside. It's all modular, and you can set lots of parameters with it. It's a very versatile chip. That, however, is being used with this microwave transistor, which can oscillate at very high frequencies, and by using this antenna, which I suppose is effectively an inductor at those frequencies, and these little pads here which couple to the negative rail in the back of the circuit board, effectively creating capacitors. By using those and these banks of little capacitors here and then capacitors and resistors here, it makes this self-oscillate at a sort of, I suppose the frequency is determined by the inductors and capacitors, but that is modulated slightly by the reflections. As you walk towards it, you're creating a disturbance, and it probably changes the load on this, which wants to run at a very precise frequency. That any movement affects that, creates a slight undulating voltage, which is picked up by this, which then does that thing where it triggers the timer inside, which is set with various capacitors and resistor values, and that drives the LEDs to the higher intensity. Is there anything else worth saying here? Yes, I can give you the current ratings. The quiescent current of the circuit is about 1 milliamp, which is nothing. That's peanuts. It's not really going to drain the battery itself, and sort of even in an overcast day when it's just barely enough light just to keep it turned off. At the 4.2 volts, the high output on the LEDs was about 1.7 amps. The low output was about 217 milliamps, so it is a very, very low setting. That's the level it will stay on all night. You could technically change that with this resistor if you could get into the case. If you made this a higher value resistor from 5.6 ohms, which is the one that limits the current at the low level setting, you could theoretically make them run at even lower intensity, but you want a modest intensity to be able to work by or see the path by before it's turned on to full intensity when you walk under it. As the voltage falls, the intensity of the LEDs will fall. I measured at 3 volts. The high setting was, when it was triggered, was 462 milliamps through the LEDs, which equates to about 1.4 watts. And the low standby setting dropped right down to 86 milliamps. So even if the solar panel's just barely struggling to put out maybe 100 milliamps on a dusky day, and I'm going to have to put this to the test, I'm going to take the solar panel out tomorrow and I'm going to test it. I think it's going to be overcast, who knows. I'll take it to the brightest bit of the garden and measure the current and we'll see what it is. But it makes me wonder, given the size of that solar panel, let's zoom back out here. Given the size of that solar panel, it does look quite generous. Is it monocrystalline silicon, it looks like? I don't think it's polycrystalline. It doesn't have that sort of pattern crystally effect. So theoretically, it's a really capable solar panel. I would expect a minimum of 100 milliamps on an overcast day and hopefully a lot more, potentially 500 milliamps or so on a bright day. And that, depending on the exposure during the day and the activity at night, would determine how long the battery is going to last. If this Doppler, if there's a lot of movement of foliage or animals walking by or people walking by, and it keeps triggering to high intensity, it is going to affect the runtime. Now, the people that complained about it, I wonder where they'd get it mounted, because there is a tendency to mount solar panels without thinking that as long as light hits them, it's going to put a charge in them. In reality, the maximum output from a solar panel is if you point it directly at the sun. And what comes to mind here is various attempts at solar power that Glasgow Council botched, and then they did properly here in the Isle of Man in Douglas. And one that comes to mind is a pavement or sidewalk. There was a shop, and the shop had a big canopy out over the front of it with this sort of signage in the front. And they put in, there's the curve, they mounted a parking ticket machine, and it had a angled solar panel on the top, and maybe they could have turned it round and angled it out the way, but they didn't. They had the solar panel pointing in like that. So the only light that could possibly reach it would be from that tiny part of the sky there just shining across the surface. So the things just never really worked properly. They needed their batteries changed all the time. Likewise, they did the same by putting bins with solar panels, compactor bins that you pull a little drawer open and you throw your rubbish in, let it close, and every so often it's got a large array of solar panels underneath. Every so often it compacts it down, so that when they pick the rubbish up, they don't need to empty the bin so often. It's all compacted into a solid mass inside. But they also struggled with the solar power, particularly because they put them in narrow streets with big buildings on either side and the wee machine on the pavement down there. So the only time it would get sunshine would have been at the peak of the day when the sun was passing directly overhead. In Douglas, they also put these bins in, but they used common sense. They basically angled them to where they were going to see a lot of sunlight, and they are much more effective. Less building height as well there, so it means that more of the sky is exposed. So I wonder if these people that complained were maybe just locating the solar light badly. Ultimately, you have to make sure it's not going to be shadowed by a building or trees or anything like that, canopies, ledges. It has to be mounted out on a stem or something that it's going to be exposed to a lot of sunlight during the day if you want a decent performance at night. But there we go. I think that's just about covered everything. This little regulator here, the boost regulator, is a W2RB. That's the DKCOZ or COZ. These transistors are Y1. Those are the little MOSFETs. That's about it. The only other thing that might have been interesting is what they've actually used as the microwave transistor. Let's see if I can read that. It's a very, very tiny little transistor. it says FCB. Not sure if you can see that. I'm not sure if I'm even pointing at the right space. FCB, not sure, I've not even checked that out. I'd guess it's just a very common high-frequency transistor. And that's more or less it. One advantage, running the LEDs at the low power, the 5 watts, means that this panel doesn't actually get too hot. And it is only being run up at that power when it's being triggered. It would normally be down about 1.4 watts with a fully charged battery. And it's a fairly large panel, so the heat from these isn't too high. The hottest components in the board are these 1 ohm resistors when they get triggered, and they went up to about 80 degrees Celsius relative to ambient, not really. I would say it's probably about 10 degrees Celsius here. So they would have gone up to about 70 degrees relative to ambient. But that would again depend, I was going to say, on the temperature inside the light, but they're not going to come on when it's like beating down with sunshine. Another thing worthy of note, the mounting of that lithium cell. They'd melted a hole in one of these sort of fins here, and they'd cable tied it on, but they'd hot melt glued it. It's worth mentioning that that is mounted well away from the solar panel. The solar panel will be absorbing some heat, but the lithium cell was protected, and it's also got ventilation holes to keep it cool. That's all pretty good. I mean, it seems quite a nicely designed little light. So the tests, I'll do those tests, the capacity of the lithium cell and the output of the solar panel in our meagre sunless weather here, and I'll put them in the description down below. And that more or less sums it up for this. It was quite an interesting light, quite enjoyed taking that to bits and reverse engineering it.